So I just want to start out by introducing the company Keystone Foundation Repair. We've been around since 1989, and I've worked there since 1999. Yep, so for me, this is 26 years with the company, and I'm proud of that. And most of our employees have been with us. In fact, the majority of our employees have been with us for over 20 years. So we work really hard to retain them. We are veteran-owned. We are still independent. A lot of our competitors have been bought up by, private equity investment companies. We're still independent and owned and operated out of Carlisle, Pennsylvania. And this is our building up in Carlisle. If you ever drive by, we have one location that we work out of. We cover an area about 150 miles out in any radius, 150-mile radius out of Carlisle. So that puts us all the way up to the New York state line, over to Philadelphia, south of DC, Northern Virginia, all the way out to Deep Creek, Maryland, Altoona, Johnstown, things like that. So, like I said, I've been there for 26 years. This photo, you can see me on the very end. Bear with the PowerPoint. We had to convert this from my keynote presentation to PowerPoint, so some of the animations might be a little wonky. But that's me on the end. This was probably about 18 years ago. So younger, and I'd like to think dumber. I'd like to think I'm smarter now, but not so sure. That's my wife and I. If you can't tell, I'm the one on the right. And this is my wife on the left. I have 3 kids. That's my offspring. This was a couple of years ago. So they're going to kill me for putting up a photo that's probably 3 or 4 years, but there they are. Now, in my house, I've always had one rule: no dogs. I was never going to have a dog. I grew up with dogs. I grew up on a farm, had dogs, on the farm, of course, my whole life, but we were never going to have a dog. But unfortunately, that changed, and we have a dog. Her name is Tig. That's Tig. There she is before a haircut. That's her after a haircut. So this is my new reality. Tig's number 1 in our home. So I unfortunately was dethroned. Who's kidding? I mean, I'm just kidding. I never was number 1. So my kids were always that. So services, just to briefly go over our services, we do sunken foundation underpinning, sinkhole remediation, leaning chimney repair, bowed wall repair, foundation waterproofing work both outside and inside, cracked wall repair, and sunken concrete leveling or void filling work. So the first section we're going to cover is foundations. So the different types of foundations that you're going to see out there when you're doing inspections. This is a strip foundation. This is a typical footer and foundation wall, be it concrete, brick, stone, or block. That's your most common foundation for basement foundations or even slab-on-grade foundations in this area. You also have the wide strip foundation. Again, it's just the same type of foundation, just with a wide footer. This is normally implemented where there's poor soil conditions. You have trench-filled strip foundations. So this is not a foundation with a footer, right? So it's just a trench that's dug, and it's either filled with concrete, like you see in this example. Sometimes it's actually filled with aggregate, with stone. Raft mat foundations. You see this occasionally, again, in poor soil situations. This is more common down south, especially in boggy or marshy areas. Again, just a reinforced concrete slab with a thickened edge, all reinforced with rebar, typically in wire. The idea is the entire foundation won't crack. You won't have differential settlement issues. It'll move like a boat. It'll move all together. Pier and beam foundations, you'll see this, especially down around the bay. And again, coastal areas, typically it's a crawl space underneath. Sometimes it's exposed, sometimes it has skirting around it. Again, just individual piers and a beam connecting the piers to support the structure. There's different iterations of this. Here's another example. Here's basically a piling. So it's still a steel pier and beam foundation here. These might be helical pilings or micro pilings installed. And then you have deep foundations. So here's timber piles like you see down at the shore, driven deep into the ground. Generally, these are friction piles, so they're not end bearing. So they actually distribute the load through the side walls of each of the timber piers. And then we get into foundation materials. So in this area in the Northeast, we have a lot of concrete or cinder block. Cinder block had cinder in it. So basically the waste from coal-fired plants, they were actually mixing in with the concrete to make a cinder block. You don't find those anymore. Most of our modern block today would be concrete, all concrete. Concrete's much harder, much more durable, much more prone to resistance to deterioration than early cinder block was. In most areas, block CMU was being used, I would say, entered the market in the mid-30s. So that's when you start seeing cinder block actually being used as a building material for foundations. Curiously, at that time, right, you got to remember, there's always technology overlap. So in Pennsylvania, for example, we had foundations built in rural areas made out of stone all the way into the 50s. So you had about 20 years, right, of both stone and block foundations, sometimes poured foundations, being installed between the mid-30s and the mid-50s. So the masons that were laying stone all of a sudden started laying blocks. They were a lot lighter. You know, they were the same size. They were this modular system. Curiously, a lot of those guys would treat block just like they treated stone. They would actually lay the first course right on the dirt. And they actually did not have a concrete footer at all. So they just dug out the ground for a foundation, leveled it off, and laid their first course. That's not a great thing, especially if it's cinder block. It's wicking up all that moisture out of the ground. But that's the way they did it. And a lot of early block walls, you'll see that they're irregular, right? So in other words, all the blocks aren't perfectly aligned with each other. The walls may not be perfectly plumb. They might not be perfectly level. And again, you got to realize the guys laying stones, right, which was more of an art than a science, were actually fitting stones all of a sudden started laying block. And they could lay lots of block all at once because this was lightweight. It was easy. It was all the same size. But those stone guys, those stone masons early on didn't care that the wall was perfectly flat, or the wall was perfectly level, or the wall was perfectly plumb, right? Because they never had to worry about those things when they were laying stone. So early walls, you'll go out and the wall will look kind of wonky. It'll look like an amateur laid up the wall. You know, it's built in the 30s, maybe the early 40s. And it's not that it was an amateur that did it. It's that guys that laid that wall were laying stone also. So it wasn't that it was not professionally done. It's not that it's a problem from a structural point of view. It's just not perfectly flat and straight, and the blocks aren't perfectly aligned with each other. That all changed shortly. After block was introduced, they started pouring footers, and they laid the corners first, and then they stretched block and line, or they used a block and line, so they stretched a line from corner to corner, and they laid the wall line block to the line, right? So after a while, everything was nice and flat and straight and plumb. Here's some more photos of CMU foundation walls. Before concrete or cinder block, you have some foundations built out of structural tile, or what some people call terracotta block. Anybody seen a terracotta block or structural tile foundation? Yeah. They also, the thing you see in the wild, I should say, is silos actually on farms. You'll see some of those silos actually, because they're visible. Most foundation walls are below grade, but you'll see silos actually built out of structural tile. Here's an example. And this is still a pretty common material in other countries. In the United States, it's pretty much non-existent anymore. And then you have cast in place concrete or poured concrete. This is probably the predominant foundation we see in residential construction these days. Sometimes you actually have board formed concrete foundation walls, cast in place concrete foundation walls. It's usually for aesthetics. People like the look of the board grain imprinted in the concrete. A lot of times these foundation walls are actually exposed on more modern homes. And then you have insulated concrete forms. So anybody see insulated concrete form foundation walls? Only a couple? Yep. Yeah, this is a really cool technology, but it hasn't really caught on like I thought it would. Basically, you stack up these blocks. They're permanent forms. They're insulated, and you fill it with concrete. It's a really good system. Surprisingly, in my opinion, it hasn't become more popular.
Cheaper than?
No, it's not cheaper. So that's probably the reason why at the end of the day. There's a lot of cast in place concrete contractors out there. They have the forms, they're putting them up, they're banging those, poured cast in place concrete foundation walls out every day. Not as many guys know what to do with this. So generally the labor costs go up. There's a bit of a learning curve that they make up for in their price, in their bid. Yeah. And then you have precast foundation walls. Superior wall is probably the most common. But there are other companies, but in this region of the country, Superior Walls, which are factory-made concrete foundation walls, pre-insulated, that are craned in and bolted together. Stone foundation walls, which we've kind of covered already. Yeah, so some of these are prettier than others, right? This is a combination of stone and brick. You'll see in cities. You also have full brick foundation walls. Again, a lot of times you'll see these in more urban areas. And metal foundation walls, believe it or not. This is a pier beam foundation, again, steel pile system driven into the ground. It's also considered a deep foundation. So you can use metal for foundation walls, and believe it or not, you can use wood. Anybody see wood foundations before? So a couple people have seen wood foundations before. Yeah, it's actually in the International Residential Code as an approved foundation construction material. I don't know why you'd ever do this, but some people do. Yeah, with the price of wood these days, I'm not sure it's cheaper. So it might have been cheaper at one point, but you also have to think about the fact that if you're building a wood foundation wall, you also have to make sure it's properly waterproofed, and you have to have all that drainage, and it's very tedious. All right, so you'll have this sheet in your folder for those of you that are here at the conference, but there are basically 4 categories of classifying the performance of a structural system. So people want to say it's either structurally sound or it's structurally, failing, right? But the reality is those are 2 ends of the spectrum. There's lots of gray area in between. So I ended up classifying or categorizing, I should say, the structural performance of a foundation. And we're going to go over that now. Again, the sheet is in there for reference for you guys in the future. So category 1 is called structurally sound. This is really a no-brainer. The system is fully serviceable without material or structural defects. Any cracks or deflection needs to be inconsequential, right? Or within the allowable deflection standards, right? So that's a foundation wall. You might have shrinkage cracks if it's a poured foundation wall. There's no displacement. There's no measurable deflection. There's really no issues with these walls. Category 2, this is a serviceable foundation wall, but it has defects. Okay, so the structural system, the foundation, which is the topic we're talking about today, is adequately or reliably fulfilling its structural function or purpose as originally designed. Okay, so the system can have defects but still be serviceable. Serviceable just means the foundation is doing its job, right? It's supporting the house, it's retaining the soil. But it can have a crack, it could have measurable deflection. It might be a bowed foundation wall, or it might be a foundation wall that has settled, but it's still serviceable at that present time, right? But that doesn't mean, serviceability doesn't mean it doesn't have a defect. It still has a defect, but it's still doing its job. Category 2. These are the walls you guys normally are questioning, right? These are the walls you're normally calling out in your reports for further evaluation. Category 3 This is kind of a no-brainer, right? The structural system is no longer adequately or reliably fulfilling its intended structural purpose. The serviceability of the system is compromised. Okay, so that's a foundation wall when you're in the basement and you're looking at it, whether it's settling or whether it's bowing, and you're with your client, and everybody knows that there's a problem, right? Everybody's saying, oh crap, what's going on here, right? Something is wrong with this foundation, right? That's a category 3. That means that long term, right, if the conditions that cause that defect to develop, right? So if the soil pressure that bowed the wall or the soft soil under the foundation that caused the foundation to sink, if there was no remedial work to address those problems, to address the conditions that caused the problem, that problem's likely to get worse, right? And nobody's wondering whether it's a problem if it's a category 3 wall. This is basically a deal killer, right? In many situations. Lots of buyers will run out with their hands, above their head. They don't want anything to do with buying that house that has a structurally failing foundation wall. And then, of course, category 4, which I'd be surprised if you guys see this. I see this on a regular basis because we're the company that fixes problems. But this is basically a collapsed wall. There's no serviceability anymore. The wall's not doing its job. It's not supporting the house. It's not retaining the soil, right? This wall has collapsed. Clearly, of all the categories that are, no-brainers, this is the most no-brainer of them all.
When you determine that a wall has moved, we'll say beyond an acceptable tolerance, you probably have different ways to figure that out. Is the 1/3 rule of stability something that you used to determine that?
That's a good question. Funny thing is there isn't. All right, so it depends on if the wall is reinforced or not. All right, so if the wall has reinforcement in it, if there's rebar in the wall, then you can calculate the allowable deflection, right, before it's considered structurally compromised. But most of those foundation walls don't develop a structural issue due to the fact that they are reinforced. Most foundation walls that you're going to inspect that do have cracks, that have settled, that are bowing, most of those foundation walls are unreinforced foundation walls, right? So it's just concrete, or it's just block and mortar, or stone and mortar, or brick and mortar. They don't have reinforcement in them, so they have very little tensile strength. So unlike other structural materials like steel for beams or girders, or wood for joists, trusses, there is, by code, there's an allowable deflection, right? Given the size of the joist, the species of wood, right? The grade of the steel, its thickness, there's lots of things that go into calculating whether that beam, whether that joist, whether that truss is structurally failing or not, or if the deflection is acceptable, right? However, there is no established deflection standard that's allowed for an unreinforced masonry system. All right, so I want you to understand that. For an unreinforced masonry system, whether it's concrete, brick, stone, or block, there is no limit, right? There's no standard that says that wall can bow, up to, 1/3 of its width or 1/4 of its width and still be considered structurally sound. So I illustrate this, and a lot of people don't know this, and a lot of engineers just make up, basically anecdotal, standards. So they'll say, for an 8-inch foundation wall, an 8-inch block wall that's 8 feet high with 100% fill against it, that wall can bow up to 3/8 of an inch and still be considered structurally sound. But they can't produce the publication that says that, because it's not real. So at the end of the day, if you have an unreinforced masonry system and it's cracked, there are 2 parts to that foundation as a system. So imagine a foundation wall with a crack running through it. You have an upper portion and a lower portion. They're no longer connected to each other. That crack exists. There's no rebar that connects the 2 sections together. right? So you've lost all tensile strength that once existed. Admittedly, concrete mortar has very little tensile strength. It doesn't take much pressure to pull apart concrete that doesn't have reinforcement in it. So I illustrate this by saying, imagine a chasm and you have a concrete beam, concrete bridge, just a beam running across this chasm from one side to the next. You have two of them, actually. One has rebar in it, laterally, long ways, and the other is just concrete. There's no reinforcement in it. Okay, which one would you walk across? Huh? The reinforced one, right? Yeah. So, and that's because if a crack develops on the underside of the unreinforced beam that you're going to walk across, what keeps it from collapsing? Nothing. Nothing. It's two pieces now, right? You need that reinforcement to keep the wall functioning as a system, right? So unlike the beam illustration, however, the foundation does have compression, right? It has the weight of the structure on it, which is helping, keeping that foundation wall from buckling in because you have compression load. It's kind of like pushing on the ends of that beam over the chasm that doesn't have reinforcement in it. It will help prevent that beam from collapsing to a point, right? Eventually it will fall. So none of us would walk across the beam that doesn't have reinforcement in it if it has a crack on the bottom. None of us are going to walk across that beam and say, hey, it's only bowing down about 1/4 of an inch, everything's good, right? Because again, there's no reinforcement, so it doesn't have tensile strength. I don't know if that answered your question. Go ahead.
That's what, Andrew, first, did I understand you say you wanted just to hold questions to the end?
Yeah, that's probably best. But let me just address your question and then we'll try to do that. Yeah, go ahead.
Okay, I apologize.
No, it's
I'm out
okay.
of turn. Great information, all of which I agree with. Not that that really matters, but I guess the reason I was asking it is you have a room full of guys that might have a client sitting in front of us
Sure.
one day, as if we haven't already.
Yep.
And it's one thing to give our opinion. It's another thing to be able to educate them and say, so when they try to determine if it's moved beyond an acceptable tolerance or not, this is what they're looking at. And here is a potential design solution that they may consider because it doesn't exhibit a lot of movement. So I'm just trying to see if you have an answer to help us
Sure.
when we have our clients sitting next to us,
Yeah.
say, this is exactly how they're going to determine what strategy they want to use.
Right. All right. So use the beam over the chasm illustration. No, I understand the problem, right? The problem is you have a client that's depending on you to tell them whether or not they should be concerned about this crack in the foundation wall or not. Generally, the answer is they should be concerned, right? If it's an unreinforced foundation, they should be concerned. Unless you know that something changed, right? That the previous homeowners took action to change the conditions that caused that foundation wall to shift or to sink. Say they regraded or they put new gutters on so the gutters aren't overflowing and saturated in soil and putting excessive pressure on the wall. At the end of the day, if you know it's an unreinforced foundation wall and it's cracked and it has measurable deflection, those are the two things you need. All right. So you need a crack and you need measurable deflection, right? If you have those two things and it's an unreinforced foundation wall, you should be calling for further evaluation at that point. When we come out to look at that situation, we're considering not just the amount of deflection in the wall, we're considering the material it was made of, we're considering the load on the wall, we're considering exterior conditions, the width of the foundation. All of those things play into the risk level that problem is going to continue to get worse. But most of us, right, unless we know the conditions changed, most of us would predict that problem's not going to, obviously it doesn't get better, but it's not going to stay the same. It's likely to continue to get worse. Even if it's slow, even if it's over a decade, it's likely to push in more or the foundation is likely to sink more. Yeah, so that's a hard place to be in though, right? And I know that you guys over the years, more and more and more, you feel the pressure to basically call for further evaluation on everything. Right? From a legality point of view, right? And I understand that. So, but that's what I'm encouraging you to do. because foundation repairs are not inexpensive, right? And you guys don't want to be on the hook, right, for not calling for further evaluation on a foundation. You don't want to be drug into court, right, because you said, that's fine. You want to put that on us. And the reality is I do say foundations are fine. They're structurally serviceable, and I can write a report. But generally, that's not the case. Usually, if you guys are flagging it and questioning whether it's a problem or not, it's usually a problem. Usually, the wall needs to be reinforced. Okay, so structural defect. So again, I'm not sure what this is doing, but let's give it another shot. Okay. Anyway, structural defect basically is a weakness or flaw in the structural system, right, that has caused the foundation to no longer perform as originally intended, right? Maybe it's the lack of reinforcement, maybe it's deterioration. That gets us to material defect. Think of this as a defect in the concrete or a defect in the block, right? And you have deterioration of the block. This is a good example in the corner, right? Just because it has a material defect and a couple of the blocks are soft and they're deteriorating, if the rest of the wall is sound and a block are not deteriorating and they're hard, it's probably not a problem, right? But if all of the block are soft and all of the block are deteriorating, they all have a material defect, that can result in a structural defect over time, right? As the wall weakens, because it works as a system. That's also in your folders, so you can unpack that. Those definitions are in there if you want to look at that later. So the first thing we're going to talk about is sinking foundation underpinning. How do you know if the foundation is sinking? Well, I mean, you have obvious examples of a sinking foundation. Like that one, for example. That's pretty terrible, right? I mean, I think all of you are going to flag that and call for further evaluation. I don't know who's considering buying that house, but somebody might, some long-term rental investor. Obviously, this is a demo, but you know, another good example of a foundation with major foundation issues. So normally you have wall cracks, right? This is the most obvious sign, right? It's wall cracks on the outside, on the inside. All signs of movement, right? So do all foundations settle? Yes, right. And that's fine, right? As long as there's an anticipated amount of settlement, uniform settlement from when the building's built. But it's supposed to stabilize, right? The problem's when it doesn't stabilize and it continues to settle, right? Or you have differential settlement. So one part of the building is settling more than the other part of the building. And that is causing the cracks, and that's pulling the building apart. Floor cracks is another sign. So in the basement, you'll see those. A lot of times the floor will crack and settle with the foundation. Crooked windows, crooked doors, both on the exterior, and you can see those on the interior as well. Some of these photos are just because they're cool. All right, so the number one cause of a sinking foundation is simple. It's soft soil. So up where I'm from in Pennsylvania, we have a lot of clay in our soil, right? So if that clay, in a dry condition, that clay is very dense. So the foundation won't settle. However, if that clay soil under the foundation becomes saturated, its plasticity changes. It becomes mud, just like this foot, right? So in a wet condition, the load of the foundation, just like the load that's being applied to that boot, will actually sink into that clay. And the clay will displace out and around the foot or out and around the footer of the foundation. So water can be a contributing factor. Water can be softening the soil. So it's not dense enough to support the load of the structure. All right, and the number two cause is unstable soil. So this is normally a deep soil problem, and everybody thinks about sinkholes in our area of the country, and that's true. You might have a deep soil problem that's causing the foundation to sink. Normally, there's evidence of this, right? Not always, but normally there is. If you have a sinkhole that's developing. Soil is unstable due to subsurface conditions or gravitational soil creep. What I mean by that is on a hillside, you can have gravitational soil creep. You can have a foundation built on soil, and that soil is actually moving and migrating down the hill, right? Which is going to have an impact on the foundation that's built on it. There's another sinkhole in another country in a playground and a tennis court. That's pretty scary. Here's a sinkhole at the corner of a foundation. Obviously, this is a problem. So this should be in every one of your reports. So solution, underpinning is the most common solution. It's basically steel piles that are driven into the ground through the soft soil down to stable soil. The conventional method was concrete. But if you're using concrete to extend the depth of the foundation, you really need stable soil within about 4 feet, because once you get under the foundation for more than 4 feet, your excavation area starts to really widen in order for it to be safe. It gets very expensive exponentially and very unsafe. So underpinning, basically you drive piles into the ground. There's brackets attaching to the footer, like you see here. This is a gymnasium, by the way, brand new $3 million gymnasium for a school that sank 4.5 inches in the corner. This is a $500,000 underpinning job in Harrisburg, Pennsylvania. Yeah, see the big old concrete column footing down at the bottom. There are like 8 piles on the inside and the outside on that column footing. All right, then we actually applied pressure and we can actually lift the foundation. And then in the end, we can actually take those jacks off and it will hold the foundation in its lifted position. Solution 2 is compaction grouting. So this is drilling in the ground, injecting very thick concrete. It's called low mobility concrete to fill any of the voids and under pressure to densify the surrounding soils. So we drill, then we hook up a high pressure concrete pump very thick concrete with a very low slump to stabilize the soil. Common misdiagnosis of a sinking foundation. This is happening all the time. What's happening here? Russ? Yes, the steel lintel is over the window carrying the brick veneer is expanding and it's pushing up on the brick. It's creating the stair step crack. And this is very common. It's actually very common for our competitors to call for underpinning at this corner, and it's not actually going to fix the problem. They want to put pilings in because they don't fix lintels. So they want to sell something, right? We actually fix lintels because we're masons. So we can tear out the brick. We can put new lintels in with proper flashing and weep screens. Yep. So there's kind of a close-up of the expanding steel lintel. So rebar expands too. So that could be creating cracks, right, in a foundation wall, but you'll see this more often. I see this very, very often, expanding steel rebar that's causing cracks in concrete in a garage floor, right? That's the place I see it more often than not, right? Somebody pulls in, it's a rebar reinforced garage floor. The water's dripping off their car. The salts are dripping off their car. It soaks into the concrete. It rusts that rebar. That rebar expands because it's rusting, creates cracks, allowing more water to get in, accelerating that corrosion process. I mean, the telltale sign is all those cracks are running usually perpendicular or parallel with each other, at relatively consistent widths down the garage floor. All right, sinkhole remediation, again, signs of a sinkhole. I mean, usually sinkholes are pretty obvious. So there's a giant hole in the ground, or in the yard. Or in the driveway or the road. So the solution, again, is compaction grouting, which we already talked about. You drill in the ground, you inject very thick, low mobility concrete to fill the voids and to fill the cavities that the water's washing the soil down through. That can get very expensive, by the way. That's a time and material job because we don't know how much concrete that's going to take. So we charge a mobilization fee to get all the equipment out there, and then we start just ordering loads of concrete. And it can get very expensive very quickly. Leaning chimney, Signs of a leaning chimney. I mean, if they have a brace on the chimney, you should be worried about that. Or if there's a brace, not like this one, but there's a strap, right? We've probably all seen straps around chimneys, right? That are wrapping around the chimney near the top, up at the eave, sometimes actually back to the roof, and they're tying the chimney back to the house because it's actually leaning away. Usually visible gaps between the chimney and the house. So the number one cause of a leaning chimney is retrofit chimneys, right? So a leaning chimney is actually a sinking chimney. It's sinking, so it's leaning. They're normally chimneys that were added to the structure after the building was built. So normally you have a full foundation. Say you're 7 or 8 feet down to the bottom of the footer. They wanted a chimney. They wanted a fireplace, or they wanted just put a wood burning stove in the basement. And they added a chimney, but the mason only dug down, even if he dug below frost, right? They only dug down, say, 3 feet, and they poured a footer and they built a chimney. Well, chimneys are very heavy. And all of a sudden, all that load from the chimney is bearing on the original fill dirt that was pushed against the foundation wall when the original foundation was built. You know, you have a couple feet of fill under that footer for that chimney, and it settles over time. This is basically saying what I just said. So the solution, again, is underpinning. Basically, same solution to underpinning or stabilizing a sinking foundation of a house or a building. Same solution there. You could do compaction grouting, but it's not really cost effective. Also, you can tear it down and rebuild it, right? You can tear it down, dig deeper, down to the bottom of the original foundation, pour the footer, and build the chimney up from there, which is the way it should have been done originally. Bowed wall repair. So signs of a bowed foundation wall, normally what you're going to see out there during your inspections is a crack, usually it's horizontal, in the foundation wall. Category 1, 2, 3, or 4. It's a 3, right? Everybody's freaking out if this is what you see in the basement. That's you're fitting your fist into that crack. That's pretty bad. I mean, that's one bad storm away from collapsing. So what we normally do in those situations is we say, oh crap, we better brace this wall in a hurry, right? Because if we don't brace it, it's going to create a huge mess in your basement. That block's going to blow in, it's going to fly across the basement, it might hurt somebody, it's going to knock out the hot water heater or the furnace. So it's best to brace it if we can't get out there immediately to fix it. That situation, a lot of times if the block are in good condition, you can actually dig out that foundation and straighten it and reinforce it without rebuilding. So horizontal cracks, that's normally what you see though, right? So I got a question for you. Do you think there's measurable deflection here? Yeah, I mean, that's a bad enough crack. There's going to be some measurable deflection. How do you tell there's measurable deflection? Wait, what? A board, right? A board, whether it rocks across the crack to see if the plane is flat, right? Right. Everybody uses a board or a straight edge or a level, right? Right. So you don't have to be real technical. I mean, you can get away with a 4-foot level on the wall. I use an electronic level, so I can get real technical if I need to. But the reality is a straight edge works. You don't even have to necessarily determine how much it's deflected. A straight edge rocking across that joint, right, tells you there's deflection. It wasn't built that way, in other words. Here's a horizontal crack in a bowing concrete foundation wall, right? So unusual. I've only seen this twice in my 26 years of working for the company. So, question, is there reinforcement in that wall? What? Yeah. You think there's reinforcement? Well, there might be reinforcement in that foundation wall, but what direction is it likely running? It's running, right. So this is a horizontal crack. So normally the rebar would run horizontally if it allowed it to crack. If the rebar is running vertically, it wouldn't crack horizontally, right? All right, so you see cracks like this. This is a double horizontal crack, and it stair steps at the corner because as the wall bows in, that horizontal crack can't usually continue right into the corner of the foundation. The corner is the strongest part of the foundation. in order for it to crack, in order for that horizontal crack to run all the way into the corner, you have to have a vertical crack in the corner, right? The block have to break to allow for that horizontal crack to run all the way into the corner. So usually what happens is the pressure is relieved by the crack stair-stepping up and stair-stepping down. That's normally what you will see. And as the wall bows in, it's actually putting rotational stress on that corner. And a lot of times you'll have another crack on the perpendicular wall just from that rotational stress. There's another example of that stair-step pattern as it runs into the corner. Shearing, wall shearing is an example of a laterally shifting wall. Here's a shear, mid-height, which is a little more unusual. Normally, you're going to find shear at the bottom of the wall, which is easy to miss because you're standing and it's down at the floor line, right? And you a lot of times don't even see the shadow if you're using a flashlight because of the angle you're looking at the wall. So shear is very easy to miss at the bottom of the wall. It usually shows up between the first and second course. Normally on a three-part foundation, you have the footer, you have the wall, and you have the floor poured. And the floor is normally poured against the bottom course in a CMU wall, right? So normally the bottom course, in those situations, the bottom course can't laterally shift because it has the floor buttressing that course.
Right.
But the second course up can shift in and it can shear. So walls also lean. So this one's leaning out. This is a poured foundation wall, cast in place concrete foundation wall. This is a garage. And the yard slopes from the front to the back. There's no room under this garage. So sometimes you have a room, they put steel girders in and corrugated steel and they poured the concrete and there's storage space or a basement under the garage floor. In this case, there isn't. They just backfilled in the inside of the garage prior to pouring the concrete floor of the garage. Well, over time, because you have 7 feet of unbalanced fill on the inside of the garage, pushing on that concrete wall, and there's no fill on the outside, right, in the backyard, counterbalancing that pressure, it eventually caused that wall to lean out. All right, so kind of talking about the cracks, here's an illustration of that stair-step pattern you're going to see. I don't know if you can see it, but over here on the far right, I have some yellow marks that are indicating that rotational stress crack that you might see from the rotational stress from that bowed wall. Sometimes there's more than one horizontal crack. Here, you don't have a rotational stress crack on the far right wall, on the perpendicular wall. Because the window's there, the window weakens the wall, right? So the window makes the wall weaker at that point. So a lot of times the stair-stepped crack pattern will actually step up to the window, and that's where it'll stop. But you still have that rotational stress. So the crack on the right is actually that hinge crack that was once the corner. It's now moved in because the crack didn't extend all the way into the corner. This is an example of a crack pattern you're going to see on a leaning foundation wall. So it's not bowing, but it's leaning, usually because it wasn't properly anchored to the framing. Okay, this is very common on a gable end, just like you see in this illustration. So you have a typical ranch house. You have a girder or beam running down the middle that the floor joists are sitting on. You have a typical gable end. All the joists are parallel with this wall. And they sometimes they didn't even have sill plates, right? It's joists right on the top of the wall. If they did have a sill plate, many times those sill plates weren't properly anchored to the top of the wall. If they anchored them at all, they might have used masonry nails, cut nails back in the day to anchor that sill plate to the wall. So these walls are prone to leaning. You'll see that crack pattern. So imagine the basement to the left where you see the 2x4s is finished. You can't see the rest of the wall, right? All you can see is this room because this is a storage room and you see a crack pattern like that, right? What do? I would tell you to get your level out because to the left of that crack, by that 2x4, you should be able to determine whether or not that wall's leaning or not, even though you can't see the rest of the wall in the finished space. That crack pattern that you see here also is on the other end of the wall. But in my illustration, it's covered up by drywall or paneling. You'll have two crack patterns like that. One on one end near the corner, one on the other end that's allowing the wall to lean. On the outside of this wall, because you have the beam sitting in the beam pocket, it's not uncommon on the exterior side to actually see the block that is covering the end of the beam look like it's punching out. And then that block isn't moving. The rest of the wall is moving and it's leaning in. That block's staying in place. The block that looks like it's getting pushed out, that block's in its original position. It's because the beam is holding it in place. Have you seen that? Yeah. All right, so this is a bowed end leaning wall. I know I'm getting kind of technical and in the weeds, but those are just some illustrations of the crack patterns you're going to see. So on a leaning wall, when you have a stair-step crack like that, does a straight edge help you? No, because that wall's still flat. It's not plumb, but it's flat, right? So that's where the level comes into play. Also, can you assume that the wall was plumb to begin with? No. Okay. So assuming this is not a 1936, 1942 wall, right? This is a wall that was professionally laid, and they used block and line to lay the wall line after the corners were laid. So a professionally laid CMU wall, the most experienced mason would lay the corners first to make sure that the house is square and to make sure everything's plumb. Then they would use a block and line and they would stretch string lines from corner to corner. And usually, well, I mean, the most experienced master mason would lay the wall line block too, but the masons in training would lay those block, and they're laying to a line, right? They're laying to a line. So normally if the corners were plumb, the wall line's plumb. So you can tell how plumb the wall was to begin with by taking a level and going to the corner and measuring the wall for plumbness on the inside of that corner. That'll tell you how plumb everything was originally. And they're not always perfect, but you got to take that into consideration when you're measuring the rest of the wall. So if the wall is plumb and then you move down the wall and all of a sudden the wall's not plumb anymore, again, we're not talking about an early laid block wall that was laid by a stonemason that was just laying a stone foundation wall the week before, okay? We're talking about a newer modern foundation. You can say, if you have a crack and you have measurable deflection, that that wall has shifted. It's no longer in its original position. It's a category 2 wall. Number one cause on a bowed wall is soil pressure. It's pretty simple. Many foundation walls are not designed with enough strength to resist the constant soil pressure against them. So like that illustration I talked about before with the garage and the soil under the garage floor that's causing that wall to lean out towards the back wall, it's true for basement foundation walls as well. The more unbalanced soil you have, right, the more dirt there is against a foundation, the more pressure there is laterally against that foundation. So very tall walls, 14 course walls, for example, 14 course high walls that have, 9 feet of soil against them, if they're not reinforced, they're likely bowing or leaning. So now, if you have a foundation wall, it's 8 feet, and you only have 4 feet of unbalanced fill against it, the risk's far lower, right? That would be a situation where the lot is sloping from the front to the back, for example, and the side wall, right? You have 7 feet of unbalanced pressure near the front of that wall, near the front of the lot, right? But as you move to the back foundation wall, that grade tapers down. This is really a problem when you have heavy clay soils, and that soil is getting saturated. So because the gutters are overflowing, the downspouts are dumping right at the corner, or the grading isn't sloping away. That soil, which was fill material when the house was built, that was pushed against that foundation wall, readily absorbs water very easily, and it puts a lot of lateral pressure on that foundation. If it's not reinforced, it's likely to continue to bow. It's likely to bow to begin with and continue to. Okay. Consequently, the foundation walls that are too weak to continually resist the strain from the soil move laterally over time. That's what we just said. So the solution is reinforcement. Basically, this is what code requires now. You cannot build a block foundation wall 12 courses tall with 7 feet of soil against it without it being reinforced. I don't care if you're using 12-inch block. You still have to reinforce it. So now the International Residential Code has a chart that tells you exactly where the reinforcement needs to be installed or how often the reinforcement needs to be installed, what size rebar to use, and depending on the height of the wall, the width of the block, the amount of unbalanced soil pressure, right? And the real confusing factor is they require you to classify the soil type. So how many builders do you know are soil engineers? So normally what you do is you assume the worst case scenario, like it's terrible soil. So that's what you do, and you reinforce accordingly. Unless you have a geotechnical engineer on site that classifies the soil, you know, normally you would just assume the worst case scenario and you would over reinforce the wall. Okay, but you can reinforce a foundation wall after the fact, right? Because a lot of walls were not required when they were built. A lot of houses, their foundations were not required to be reinforced. In fact, in Pennsylvania, for those of you that cover that area, foundation walls, residential foundation walls in PA were not required to be reinforced at all until 2004. Isn't that wild? Is when the state adopted the International Residential Code of 2003 in April of 2004. They did not require reinforcement. So there's literally millions of homes without reinforced foundation walls. All right, so rebar and concrete, that's one method. You can fill the hollow cores with rebar and concrete even after the fact. This is what code requires, by the way. They will require a block foundation wall to be reinforced with concrete and rebar if it's being built new. It's harder to do after the fact, right? Because you have the house sitting on top of the wall. So normally we have to cut holes into the block in order to get the rebar into the wall. Here we show an excavated wall. So this was a wall that was bowing in so much, we had to brace it, we had to excavate it, we had to straighten it, and then we had to reinforce it with concrete and rebar. Here we are inserting rebar into the wall. This is number 3, so it's only 3/8 rebar, but it's the only rebar you can get into a wall because it's flexible enough. So at the end of the day, you add a lot more rebar than what's required. And then we pump in at a 7 slump, a 4,000 PSI concrete grout. Again, no aggregate, it's just Portland and sand. And then usually if we dig out the foundation, it's waterproofed with an insulation drain board. Normally there's a footer drain installed with stone, you know, and filter fabric that goes to daylight or goes to a sump pit system per code. And then we backfill. And the outside is parged, as you can see, to cover up the holes we cut through the wall. Carbon fiber, this is the thing you're going to see in a basement. If the wall's filled with concrete and rebar, you may not have any evidence that that was done. Unless you can see those holes, right, cut in the exterior in the top course. So carbon fiber, though, is very obvious. Basically, the joints are repointed. The carbon fiber is applied to the wall with epoxy. So if the wall's painted, you have to grind the wall before you epoxy the carbon fiber to the wall, okay? Every carbon fiber distributor requires the epoxy to bond to the block, right? Not to the paint. So if you see a carbon fiber strap reinforcing system in a basement, and you can tell it was applied right to the painted foundation wall, it wasn't installed correctly, and it's going to fail. Because now the bond, that carbon fiber strap's bond to the wall is only as strong as the paint's bond to the wall. And it's very weak. It'll eventually fail. Carbon has gotten a bad name. And it's because there's lots of incompetent people, or I should say, poorly trained companies installing this system when they shouldn't. and they're failing. So there are people, engineers even, that are saying, I don't want to use carbon fiber straps, because I've seen too many failures. Again, it normally comes down to improper ignorance and improper installation techniques. So the epoxy is applied, the carbon fiber strap is applied, it's pressed to the wall, another layer of epoxy is installed. We removed the tape in this case. Sometimes it's taped, sometimes it's not. So carbon fiber straps are on the tensile face of the wall, the tension side of the wall, right? So how does it work? In order for that wall to bow in, that crack you have in the wall, the horizontal crack, what happens to that crack as that wall continues to move laterally? It opens up, gets bigger, right? With carbon fiber installed on the, again, inside face, the tension face of the wall, in order for that wall to shift and that crack to become wider, that system, that carbon fiber strap system has to either stretch, so the carbon has to stretch to allow for that wall to shift, or it has to delaminate from the wall. They have a very high tensile strength, so they don't stretch. They don't delaminate from the wall, assuming they were installed correctly, because the pressure on that strap is in line with the plane it's adhered to. I illustrate this by saying this table down here, if I took duct tape, just standard duct tape, I taped the top of it, and I had a 3-foot piece hanging off the end. And I pulled parallel with the surface of that table. Could I peel the duct tape off? No, I drag that table across the floor. If I peel straight up perpendicular to the surface, would it peel? Yes. Carbon works the same way. So that's why carbon doesn't work in all circumstances. So if you have displacement between the courses of blocks, shear, it will not work in that case because the wall can shift and start that carbon fiber strap to peel. Steel braces is kind of it's a conventional, very old way of reinforcing a foundation wall, but sometimes it's appropriate. Carbon fiber is basically the contractor's most simple solution, right? Because steel, because it's attached to the floor and it's attached to the floor framing, they don't care whether the wall was leaning, bowing, shearing, doesn't matter. This will stop it from moving, right? So a lot of companies will install steel braces. We do too, because it works in all laterally shifting foundation wall scenarios. So they don't have to properly train their sales guys or their inspectors. They just tell them, go out and sell steel. And the company's protected, right? So the company then puts steel on the wall. The inspector, the sales guy, doesn't actually have to understand whether it's appropriate or not, like they do with carbon fiber straps. They just go out there and sell steel braces. As long as they're not too far apart, it'll keep that wall from shifting. By the way, that brings up a different topic, whether it's steel or whether it's carbon fiber straps or whether it's buttresses, which we'll get into that, like masonry buttress walls, perpendicular to the wall to keep the wall from shifting. 4 feet is your max spacing. 4 feet between steel brace, between carbon fiber strap, or between buttresses. And it's not a weakness of the carbon or the steel or the buttresses. It's a weakness of the wall. So if you go out and you look at a foundation that's been reinforced with steel or carbon or buttresses, and those reinforcements are more than 4 feet apart, say they're 6 feet apart, that wall can buckle between. It's a weakness of the wall. That's what the problem is. It's not a limitation of the reinforcing method. Okay. Anchored to the floor, like I said, anchored to the floor joists. Tiebacks, this comes back to that garage wall I was talking about that's leaning out. How in the world did we reinforce this? You have soil on the other side of the wall and a garage floor covering it. In this case, we cut with a core rig through the wall. That's what the soil looks like under the floor. We use tieback anchors. These are helical type tieback anchors. They're giant screws that are screwed through the soil under the garage floor. Actually, this particular job, they went past the front of the garage and underneath the driveway. Then there's steel plates that are attached to those tiebacks to keep that wall from leaning. And then we actually epoxy injected that crack at the corner. Reinforcing walls, okay? Like a buttress system. Sometimes you can't rebuild the wall. You can't use carbon. You can't use steel. Sometimes you actually have to build a badass, super reinforced block foundation wall in front of the foundation wall to keep it from moving. And that's what we're doing here. This is a special structural block called Ivany block. It's designed to have, has grooves in it. So it's designed to have horizontal and vertical rebar in it. There's no head joints where grout doesn't end up. It is filled completely with concrete grout at the end. The space between the two walls is filled with grout. I mean, it's basically a bomb shelter wall is what it is. And we even after all of that, we installed an angle iron bolted to the girder. Just because we could. So, wall reconstruction, right? So nobody's questioning this is a category for, yeah, wall collapsed. So we can rebuild the wall per code with reinforcement in it, obviously. Outside's parged and waterproofed and footer drains are installed. The wall's filled with grout, just like before. All right, now we're going to get into bowed masonry walls above grade. So there's two types. You have a composite masonry wall and a masonry veneer, right? So brick veneer. What I'm talking about in most areas, we're talking about structural brick walls above grade that are multiple layers thick. So we're talking houses built prior to 1935, mid-30s and earlier, okay? In most areas. So those walls are built with multiple layers of brick. Anybody know the name of each one of these layers? No, that does apply, but not to the layer. They're called widths. Yep, W-Y-T-H-E, right? That's two widths, what you're looking at there. Some people say widths, but that's not correct. So here's a top view, right? Here's your headers you were talking about. So the headers are bricks that are turned 90 degrees to tie the widths together. You see that at the very top? Okay. Now, depending on how often they installed those headers that are tying those widths together, they have different bond patterns, is what they're called, brick bond patterns. And this is something I just to geek out about, so bear with me. Ultimately, you have to have headers that connect both widths. Sometimes you have 3 widths or 4 widths, but residentially speaking, it's normally 2 or 3. The headers you can't see that are tying together a triple width wall that are tying together the middle width and the inner width, right? Because they're all invisible. You can only see the ends of the headers, right, on the exterior. So this brick bond pattern is called stretcher bond or running bond. You can have this pattern, right, on a structural brick wall, but where are the headers? They're one layer in, but how does the exterior layer attach to the interior layer? On an angle. Who said that? That's impressive. Yes, on an angle. They're called hidden headers, right? You can't even see them. But what they did is they, instead of turning the brick 90 degrees, they turned the brick 45 degrees. And they cut the exterior brick that you can see to accommodate that 45-degree angle header and hide it behind the exterior width, face of the exterior width. You can't even see these headers. Again, this is the way a common brick veneer would look too. But if it's a brick veneer, we're talking post 1935, right? On the inside, it's a wood framed home or it's a block wall, right? You don't have headers in that case, in most cases. So it wouldn't be a hidden header scenario, right? If you had a brick bond pattern that looked like this. We're talking early multiple width structural brick walls. This bond pattern is called third bond. And again, you can have hidden headers here as well. This is the most common brick bond pattern you're going to see. So you can see there's a header course and there's a header course. Fortunately, they're like a little, they're slightly off color, so they show up really well. So that is called American bond or common bond. This is the bond you'll see most often. Here you have a brick bond pattern that, and I don't know if you can see it, you can see the ends of the bricks. It's in this case, it's like every 8 courses or so, right? But the headers aren't continuous, right? They have a stretcher and then a header and a stretcher and a header. This brick bond pattern is called the Flemish stretcher bond. Here you go. This is also fairly common. So every other brick, you have a header. And again, you're looking at the end of the brick, tying the widths together. This is called Flemish bond. Okay, this I love. This is one of my favorites. This one and the next one. You have every other course, you have a header bond. This is called English bond. And then you have a variation of that. This is also English bond, but here's the variation. English cross bond. So this is a little hard to tell, but you see the stretcher course between the header courses? The next stretcher course up is offset 50%. It's staggered. I know I'm geeking out, I get it, right? And then this is an interesting brick pattern. This is usually used on interior walls because it's not usually visible on the exterior, although on occasion you'll find it. The brick here are actually turned up on edge. And you still have headers, and you still have multiple widths. This name's, oh, I'm sorry. I retract what I just said. I lost track of my sequence here. This is Sussex bond. These bricks are not laid up on edge. What you have is you have a header, and you have 3 stretchers and a header, 3 stretchers and a header. So, and then you also have what's called monk bond, which is 2 stretchers and a header, 2 stretchers and a header. I know. This is like school all over again. This is the pattern I was talking about. These are the bricks that are sitting up on edge. This is called rat trap bond. This is what it looks like from, well, that's an exterior view, but this is what it looks like from the top. It actually creates hollow cavities in the wall. Hence the name rat trap. Rats, especially if they can get inside the wall, right? They can many times move around, create a nice little home in there. That's showing you the difference between rat trap and Flemish bond because the pattern actually looks the same. It's just that rat trap, the bricks are set up on edge, and Flemish bond, they're not. Oop, go back. All right, signs of a Boeing composite foundation wall, or not foundation wall, exterior brick wall. So have you guys seen this? Yeah, so you have a structural brick wall bowing out. Here's a job in Reading. See the missing brick? I showed up. It's hard to take a photo of this bow, right? A bow in a structural brick wall above grade. This is bowing out a lot. It's hard to tell. Yes, right. And the wild thing is I showed up and I had to explain what was going on, right? How the wall was built and why it's bowing. I said, why are these bricks missing? And they said, well, we had a mason come out and they told us that they could tear the brick veneer off and relay it. So they hired them. They came out to do the job. They started to pull the brick out and they realized I'm in over my head here. This isn't just a veneer, right? This is a structural brick wall. This is a mason. I know, shameful. I don't know what's happening, but okay, it did finally land on the image I wanted to show. You can also have composite walls, right, that aren't brick, that are stone. So again, they're multiple layers of stone. They can be 20 inches thick, just like a stone foundation. They're not using 20-inch stones. It's almost impossible for guys to lift those stones that are that big. So what they do, when you have a stone foundation wall or a stone composite wall above grade, they're using 7, 8, 9-inch stones, wide stones. And they have 2 layers. And there's headers here too, right? But you can't really tell which ones are headers because the stone are so irregular. So they actually have long stones that they turn to tie the 2 widths of stone together, the 2 layers. This is bowing out. That's a stone composite wall that's bowing out. So you're going to see masonry cracks when you're inspecting a house. There's cracks at a corner from the wall bowing beyond. So the solution is threaded rod tiebacks. What's another? Does anybody know another name for these? The proper name? Nope. It's not star bolts. There's lots of names for these because nobody really seems to know what they're called. They're called patras plates. Believe it or not, they're called patras plates. They come in various styles. They're a lot of times in our area, right? We use cast iron stars, but they can be small round discs like washer plates. I'll show you examples. There's various different type of retaining plates for patras plates. And basically, these threaded rods are installed. They're a threaded rod. You drill through the outside, you run the threaded rod back, and you anchor it to the floor joist framing. Sometimes you need blocking between the floor joists to make it rigid. And then you put these washer plates on the outside. That's a house in Gettysburg, Pennsylvania, where that wall was bowing out. Again, those patras plates are lined up to tie back to the floor joist between the first and second floor. Pattress. Yep. Okay, so that's the finished job. You can see those little stars. I mean, that was perfect for Gettysburg, using cast iron stars. So retrofit patras plates, ones that were added to the building after the building was built, right? You're normally going to have multiple patras plates, somewhere between 5 and 7 feet apart. However, across the pond, they actually used to install patras plates during the build, right? Original construction. So a lot of those would only have one patras plate. They'll have one, it's original, right in the middle of the wall, right? Between the first and second floor, between the second and third floor, to hold that brick wall in place. And from new, you probably only needed one, right? But once it starts to move and the cracks develop, you need a lot more than just one patras plate. There's another example of a different style. These are just various styles of washer plates. They can get real elaborate, not like that one, but like that one. This is in Reading, Pennsylvania. It's hard to see them because I know this is in an up-close image, but I think I have one. So they're between every floor, between every window. That's a factory, obviously, an old factory. And then you have a veneer. So you can also have a brick veneer that's bowing. Is the veneer structural? Right. It's not structural, it's a cladding, it's a siding. This can have a structural load-bearing block wall behind it, or a wood-framed wall behind it, or steel-framed wall behind it. And they bow out as well. So usually that's because it lacks wall ties. So they didn't properly install wall ties, brick wall ties, when the brick veneer was being laid, or they've rusted through because they got water infiltration behind the brick veneer around the windows. There's various different styles of wall ties. Here you can see a strap style that's rusted. Again, signs of a bowed brick veneer. This is where you're going to see it most often, is a gap between the window, the brick molding around the window, and the brick itself. Also, half veneers on those houses where they brought the brick veneer up halfway, and the siding comes down to it, right? And they've caulked along that edge because they didn't install proper flashing back in the day. You'll see it's been caulked and it's been caulked and it's been caulked, right? Because what's happening is that brick veneer is leaning out because it doesn't go all the way to the eaves. Now, on that point, you need to realize that because the brick veneer sits on top of the foundation wall, or it sits on the brick ledge. If you have a half veneer, or even if you have a full veneer that's leaning out, many times it's related to the inward bow of the foundation. So the brick veneer come down, they sit on top of the foundation wall. As that foundation wall bows in, the brick veneer bows out. So if you see a bowing brick veneer on a house, check the foundation. It's actually very common. It might be the most common reason why, besides the lack of wall tie anchors, brick veneers bow out, is because the foundation wall is bowing in. This is veneer on the end. You can see the bow because it doesn't wrap around the corner. So the solution here is retrofit wall ties. So they actually make these beautiful stainless steel retrofit wall ties that you can install after the fact. Basically, you would drive these in through the wall, through the mortar joint, and they would tie back to either the interior block width or the framing. And then you patch those holes. And that will stabilize that brick veneer in place and keep it from leaning out. Here is that same house in Gettysburg that I showed you the pattress plates on. This is on the other end of the house. This brick veneer was on an addition on that house. They veneered around the original log home. So you could only see the logs on the inside because they exposed them, but on the outside it looked like a brick house. Well, to anchor, because it was moving back in the day, to anchor the brick veneer back to the logs, they installed these old wall ties. These are retrofit, just like forged blacksmith, style stakes. And they did have a couple of these old lag screws with plates as well. Well, I was so curious, I found one that was loose, and I could pull it out of the wall. And this is what it looks like. So they actually staked that brick veneer back to the logs. Pretty wild. All right, foundation waterproofing. They got a problem. See the breaker box in the corner? Yeah, there it is. That's the breaker box. And you all know, look at this. Gas meter on the inside, right? So, yeah, I think it is on the one side, yeah. Obviously, you don't normally see a situation like this, or maybe it's not even this extreme. I do have waders, but I don't always carry them with me. I have rubber boots. But if it's that deep, I'm not normally walking through there. So we normally require that they pump it down first. But this is nothing. This is what you will see sometimes. Those poor folks were finishing their basement and then they had water in there. Probably new homeowners. They're all excited to finish their basement, and they went down there a month after they bought the house, and then it rained and they got water in the basement. And now they're mad at the previous owners, right? That's how it goes. And they're mad at the home inspector, right? So a lot of times you'll see leaking walls like this. High humidity is another sign of issues, condensation in the basement, especially on, duct work and the walls and windows. Mold and mildew is another sign of water moisture problem in the basement. Oh, it gets way worse than that, as I'm sure you've all seen. Efflorescence, what is it? Yeah, it's salt deposits. It's minerals basically that are left behind. So as the moisture, it's called vapor drive, the moisture moves from the wet soil, so the wet zone, through a foundation wall to the dry zone, which is the air in the basement, and naturally moves through the foundation walls, and it evaporates off the interior face of the foundation walls. It leaves the minerals behind, right? Because it doesn't evaporate with those minerals, and they build up over time. All right, discolored blocks, again, a sign of moisture coming through the foundation wall. All right, so the number one cause, right, of water or moisture problems in the basement, I have no idea why it's doing this. I don't know if that will actually show up. Let's give it a shot. Go back one more. Go back. All right, so the most common reason why, right, is the foundation wall wasn't properly waterproofed on the exterior to begin with, right? It doesn't have any kind of waterproofing membrane. It likely doesn't have a footer drain on the outside of the wall. It just has soil against the wall. And if that soil is getting saturated from poor grading, overflowing gutters, or downspouts dumping at the corner, that moisture is going to seep through the foundation wall, whether it's block, stone, or concrete. Doesn't matter. That moisture is coming in. And many foundations also don't have adequate stormwater management around the outside, which we just mentioned. So the grading isn't sloping away properly. The gutters are overflowing. The downspouts aren't piped away. So the solution is waterproofing. The most common approach would be interior drainage systems. All right, this is where they call them French drain systems. They break out the floor around the perimeter, right? They dig a trench, they install a perforated pipe or channel with stone, a sump pump system that pipe connects to. They drill weep holes in the bottom of the block wall, if it's a block wall, to allow any water in the hollow cavities to drain out and go under the floor, into the pipe, and over to the sump pump. And then before they put the concrete back, they normally put what's called a drain board in, which is just a plastic sheet material with dimples that lays across the toe of the footer and up the wall, so that any water coming through the wall higher up can run down the face of the wall. And rather than hitting the floor and running across the floor, it creates a gap for that water to go down and under into the pipe. So you break out the floor. By the way, what is this waterproofing? Nothing. Somebody said nothing, right? It's not really a waterproofing system. It's a water management system. That's what it is. It's a drain system around the perimeter. Is it stopping the water from coming in? No, it's not. It's not stopping the water at all. It's actually, because they drill weep holes in the bottom of the block wall, it's actually inviting water in. Right? What it's doing is it's preventing the water that's coming through the foundation walls from flooding the basement floor. That's what it's doing. That's its waterproofing. So it's not the most ideal solution, but it might be the only solution that somebody can afford, right? If they're having a flooding basement problem. Again, break out the floor, drill weep holes in the wall. I don't know if you can see that, but that's actually a stream of water coming out there, because the hollow cores hold water. There's the sump pump system. There's a stone and channel and stone and a drain board you can see on the right, plastic. Then you reconcrete the floor, install the discharge line. Again, not really a waterproofing system. This is really true waterproofing. So basically, you stop the water from coming through in the first place. You actually waterproof the outside of the wall. We use a sprayed-on membrane, as you can see here. This is a 4-layer system. Then we use a 10 mil thick Stego wrap product or yellow guard plastic. We do another layer of the rubberized membrane, and you can see the insulation board there as well to protect it. There's a detail strip at the top to make sure soil doesn't get behind that system. Footer drains, stone, and hopefully to daylight, right? Hopefully that footer drain can go to daylight. If it can't, it has to go back into the house into a sump pump system. And then sometimes the solution is just a good dehumidifier, because the basement's not actually flooding. You just have that vapor drive. You have that moisture moving from wet zones right on the other side of the wall, or maybe even underneath the basement floor. You have moisture pushing through into that basement and evaporating into that basement airspace. As that moisture evaporates into the basement airspace, it's elevating the relative humidity, right? And that can be a problem, because over time, all the wood, all the boxes, they're absorbing that moisture out of the air. And what happens? Mold, right? So sometimes you just need to dehumidify. You need to control the amount of moisture in the airspace in the basement to stop mold and mildew from growing. You don't actually have physical water on the basement floor. Cracked wall repair. I'm going to try to blow through this. All right, so what I'm talking about here specifically is I'm talking about cracked foundations or cracked poured precast concrete foundation walls. There's two ways of repairing those cracks. One's injecting those cracks with urethane, and one is ejecting those cracks with epoxy. So I got a question. So you have a poured foundation wall, and you see vertical cracks. Sometimes they're not vertical, sometimes they're angled. They're not normally horizontal, but sometimes they can run horizontally, especially around a corner. What are they from? Expansion and contraction. Shrinkage, yep. So they initially form from shrinkage. When the concrete walls are poured, well, let me first ask this question. Has anybody in residential inspection, during your residential inspections, if some of you inspect commercially, has any of you seen an expansion joint in a poured concrete foundation wall? No, unlike a sidewalk, right? Where there's an expansion joint every 4 or 5 blocks, right? Sometimes less. So when they pour this foundation wall, it's one continuous slab all the way around the perimeter. The chemical reaction that takes place for the concrete to harden and cure generates heat. And between those forms, the concrete warms up. Then it cools. As it's hardening, it starts to cool. And you'll get a lot more dramatic thermal curve, right, in the wintertime, because it'll cool down to ambient air temperatures, because it's exposed, right? It's not a heated home, it's a new home. Then, for about a year or so, the concrete walls will dry out. Moisture in the concrete will evaporate out of the wall. So there's this initial shrinking that takes place from the thermal reduction after the wall is poured and the concrete's cured. And then there's this shrinkage that takes place from moisture reduction. As the walls dry out, you have further shrinkage. And because you don't have expansion joints to allow for that shrinkage, the walls create their own. They crack. And they normally crack at windows, at door openings, and at beam pockets, because that's a weakness in the wall system. Are they structural? No. However, you can have a crack that is a structural crack, right? The result of structural movement that looks just like a shrinkage crack. It's just too early to tell if it's a structural problem or not. Okay, so you got to wait and see, right? So most of the time, though, on a poured foundation wall, these cracks you're seeing in the walls are just shrinkage cracks. Now that they've formed, right, especially walls that are somewhat exposed to the outside. So say you only have 3 feet of fill against the wall, and 4 or 5 feet of the wall is exposed to the warm summer months and the cold winter months, and especially the hot sun. Those walls, because they cracked from shrinkage, now created their own natural expansion and contraction joints. So those cracks actually allow the wall to expand and contract between the winter and the summer, especially if they're exposed on the exterior. Now, if they're covered in dirt, right, from the top of the wall down, they don't move. They're mostly thermally stable. So when you inject those cracks with urethane, you do that because sometimes those cracks can allow water to leak into the basement. And when you inject them with urethane, you put a material in there that allows for that expansion and contraction while maintaining a watertight seal. If you use epoxy, that glues the wall together again. What's the problem? It cracks again because it's trying to expand and contract, right? All right, leaking cracks and openings, just like I said. There's a trash can catching all that water. Pipe penetrations is another source of leakage in a poured foundation wall, right? Because that's a penetration through the wall. Water can come through the wall there. And what am I showing here? This is a form tie, yeah. And there's moisture coming through. Why? Yeah, it's rusting, it's metal. There's literally hundreds, if not thousands, depending on the size of the foundation, of form ties running through the wall. If the exterior side of the wall wasn't properly waterproofed with a membrane, what's going to happen to all of those form ties? They're going to rust over time. And then all of a sudden, you have a hole through the wall that's a 1/16 of an inch wide and about 2 inches high. So this is a ticking time bomb. At the end of the day, if the outside of the wall wasn't properly waterproofed, you're going to have potentially dozens or hundreds of holes through your poured foundation wall after a while that can leak water. They can be injected, by the way, but it's a pain in the rear to inject every single one. So sometimes it's easier just to dig the foundation out and seal the outside. There's a crack at the corner of the window. Again, that's normally where you're going to see these. Again, we already talked about the reasons why they form, but here's the reasons why they leak. They're not sealed on the outside, and the soil's wet. So again, the solution, like we already talked about, is urethane injection. You basically drill into the wall, you install injection ports, you inject liquid urethane into that crack. It seals the crack all the way to the dirt, all the way to the outside, and it keeps them from leaking permanently. And then the last thing is pretty basic. It's sunken concrete. So structural? No, it's just a driveway slab. You know, a lot of slabs aren't structural. They can be, right? You can have a structural slab on a monolithic foundation, right? That's when the floor and the footer were all poured as one continuous slab. Then part of that, of the perimeter of that concrete slab would be structural because it's essentially the footer. But normally they're not structural. It's just sidewalks, driveways, patios that have settled down because the dirt underneath, the fill dirt around the house, when the house was built, settles, and the concrete's sitting on it, so it settles as well. Here's an example of a patio. Fortunately, it's sloped away the proper way. Steps, this is a hazard. I hope all of you are flagging that step rise onto the porch. And that's a porch on the back of the house. All right, settling fill, like I said, that's why these concrete slabs sink. The solution is mud jacking or foam jacking, right? Either one, we do both. We usually use grout to lift and we use foam to stabilize because foam continues to expand after you inject it, and sometimes it's hard to control exactly where the lift's gonna stop, so. All right, before and after. In proper pitch, that's a little better. That is a small patio. That's a little better, right? Nobody's going to trip down. Well, they could still trip down that set of steps, but it's less likely. All right. Any questions? Yes.
Just trying to get an idea on what the cost is for lifting up that concrete back to where you want it to be.
Yeah, it depends on how far away you are from us.
Which was my next question, because you said you go about 100 or
150 miles, but as we get further and further out of Carlisle, right, we become more and more selective of what we're going to do. Concrete leveling is usually limited to more like 90 miles out of Carlisle. So there are lots of companies that are doing mud jacking or foam jacking work. The prices, in my experience, are all over the board. You're going to get, like, say, the best example would be like a front sidewalk, right? Out the front door over to the driveway. You know, say it's like 5 or 6 blocks. You know, it's all sunken. You're going to get prices anywhere from $600 to probably $2,600. Yep. Anything else?
Back at the beginning, you were talking about different classes of structural failures.
Yep. Try again.
How's that?
Yeah, I think.
At the beginning, you were talking about classes of different structures. I've seen some instances where they go into the crawl space and dig it out to make more room under there.
Yep.
And now the foundation's not properly supported.
Yep.
What kind of class is that going to fall under, and what would you do to repair it?
Yeah, so that's a really good question as far as classifications go, because if the foundation itself hasn't moved yet, right, it would still be classified as a 1, right? Because you don't have any cracks, there's no shifting. But because they excavated and they over excavated to deepen that crawl space, and if they excavated right up to the edge of the footer or up to the wall, there's a real risk there, right, that movement will occur. So to be fair, if it hasn't shifted, it's still a 1. but it's, in my opinion, there's a really high risk that there will be a problem there and it should be addressed, but it doesn't really fit into those categories. Yeah, so normally that's the easiest way to do that is to build a retaining wall in the basement. So with reinforced concrete block, that's usually the simplest way because you want to retain that soil. If you drive piers in, the piers aren't continuous, so they don't actually, they'll stop the foundation from sinking, but they won't stop that soil from pushing in or falling into the basement. So normally it's a retaining, like a masonry retaining wall system. Yeah.
I heard, I don't remember exactly where I heard it, was presentation, that if a crack in a horizontal crack in a CMU wall is wide enough for you to fit your business card in, it needs to be addressed. True, false, inaccurate?
I don't remember saying that, but somebody might have. But basically, again, I'm going to go back to if you have a slight crack, so say it's the width of a business card, right? But it's not, your straight edge doesn't rock across it, and it's plumb. What category?
2.
1.
1.
You have to have 2 things. What are they?
Oh,
Cracking,
displacement.
measurable deflection. Right, yes, deflection and cracking. You have to have both, right? Because if you have just deflection but no cracking, it might have been built that way, right? And if you have slight cracking, at the end of the day, if you don't have a level, I mean, you got to draw the line somewhere, right? And your level's not rocking across it, and it's nice and plumb. It matches the plumbness of the corner because you did your job and you measured the corner to see how plumb everything was to begin with, right? I wouldn't, if I were you, I would call for just repointing that crack. But if you're straight edge rocks or you are out of plumb and you have a crack, then it's a category 2.
You also want to look at the location of the crack, not how high up is it on the wall,
Sure.
but in relationship to the grade, because it could simply be a frost line crack without any displacement at all. So.
Yes. Okay. Frost line cracks. That's a good question. The only time that you would have a frost line crack in a foundation wall in our area of the country is if that house was vacant and unheated. Because the soil against the wall, especially an uninsulated wall, if that house is being heated, you have enough thermal energy moving through that foundation wall to prevent that soil from freezing hard enough to crack the wall. This isn't true in other areas. Up in New England, or in Canada, that's a different story. But down here in Maryland, Pennsylvania, that soil typically against the foundation wall, even in the hardest freezes, because we don't have long enough, cold enough winters, doesn't freeze deep enough to crack that wall. The exception would be is if there's ponding on the other side of that wall, right? So say the negative grade and the gutter's overflowing and literally water sitting there. Then that ice can actually freeze and push on the wall hard enough, especially if the house isn't warm or it's not being kept warm in the basement. Regardless, though, once a crack develops in a foundation wall, you've lost the tensile strength, right? So you should consider that fact that you have 2 pieces of the wall now that are no longer interconnected. So the risk really increases that wall is going to be a problem in the future.
I know the frost line crack in our area is about 18 to 22 inches down.
Let me talk to you afterwards if I could.
Okay.
Yeah.
I was just
So
gonna ask where it was in Canada.
yeah.